All right, this video is over nth roots and simplifying down radicals. Okay, first let's review over the perfect square list. Now remember, to get this list, you just take each number and you square it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared, 8 squared, 9 squared, so on and so forth, and you just work your way up, okay? Perfect cubes is the same thing, but this time it's to the power of 3. So 1 to the power of 3 is 1, 2 to the power of 3 is 8, 3 to the power of 3 is 27, 4 to the power of 3 is 64, so on and so forth. Perfect fourths, same thing, but to the power of 4. 1 to the power of 4 is 1, 2 to the power of 4 is 16, 3 to the power of 4 is 81, 4 to the power of 4 is 256, and so on and so forth. Okay, so that's how you get that list right there. The different parts of a radical, so it says the nth root of a real number a can be written as a radical expression, nth root of a. Okay, the n, that tells you your index. That tells you if it's a square root, cubic root, fourth root, so on and so forth. Okay, if there is no index, so if there's not a number there, then it's assumed that n is 2, which means it's a square root. Okay, this symbol right here is your radical sign. And then the number that's underneath, or whatever is underneath the radical, is called your radicand. Okay, so it says give all possible roots to the radicals below. So the square root of 16. Well, remember when you take the square root of 16, it could be a positive 4 or it could be a negative 4, because 4 times 4 is 16 and negative 4 times negative 4 is also 16. So you would say plus or minus 4. Okay, square root of 121, same thing. So plus or minus 11. 289, plus or minus 17. 4 over 25, just take the square root of each part. So it's plus or minus 2 over 5. Okay, now when you do the cubic root, okay, it's not going to be a plus or minus. Okay, it's just going to be the positive. If it's a positive number here, it's just going to be the positive. And you can type this in on your calculator and you will see that when you take the cubic root of 8, which on a graphing calculator, or if you have the TI-84 calculator like you're supposed to download it on your computer, then you would go to math, and then I believe, let me pull it up. Well, second, no. Come on. Sorry, my calculator's loading. Okay, second mode. I'll exit out of that. There you go. Okay, so if you go to math, and then number 4 is the cubic root. Okay, if you look on number 5 where it says x and then the radical, that x means, like if you type that in, that means that you can plug in any root. So to do fourth root, that's what you would have to do. And you just type a 4 in, and then you would just type in whatever you need to underneath the box. Okay, so that's how you do those. So the cubic root of 8 is going to be a positive 2. Cubic root of 343 is a positive 7. Cubic root of negative 125 is negative 5. And the cubic root of negative 1 over 27, well, the cubic root of 1 is 1, and the cubic root of 27 is 3, so it's negative 1/3. Okay, now the fourth root. Fourth root of 1 is plus or minus 1. Fourth root of 2,401 is plus or minus 7. Fourth root of 4,096 is plus or minus 8. Fourth root of 81 over 16, plus or minus, the fourth root of 81 is 3, and the fourth root of 16 is 2. Okay, so some rules here. So if your index is an even, meaning it's square root, fourth root, sixth root, so on and so forth, and the radicand's a positive, so the number underneath the radical is a positive, your roots are going to be real numbers, and you're going to have 2 of them, because you're going to have a plus or a minus. If it's odd, the index is odd, so you have a cubic root and it's positive, it's going to be a real number, only 1 root and it's positive. If it's odd and we have a negative number underneath here like this, It's still real. There's one root, but this time it's going to be a negative. Okay, if it's even, if the index is even and the radicand is a negative, so underneath here, it's going to be imaginary, so you're going to have an I, 2 roots, and it's going to be plus or minus. Okay, so simplifying down some radicals. So it says if a radical has more than one root, the radical sign indicates only the principal or positive root. So what we're talking about on these right here, we're not going to worry about the plus or minus right now. Okay, so the only thing that we're going to worry about is just simplifying this down. Okay, so what we want to do, we have the square root of 117. Okay, square root, so we're looking at our perfect square list. You want to find the largest perfect square that goes into 117 evenly. So 117 falls on our list right here. So we're going to work our way down, dividing by each of these until we find the largest number that divides into it evenly. So does 117 divide by 100 evenly? No. 81? No. 64? No. Keep working your way down. It divides by 9 evenly. Okay? And it's 9 times 13 is 117. The square root of 9 is 3. So our answer here is 3 square root of 13. Now, typically, you would put a plus or minus in front. We're not worrying about that right now. Okay? That's not our goal right now. So you just say 3 square root of 13 because all they want us to do right now is the positive. Okay? The next one, it says 4 times the square root of 320. So that 4, we just pull it down and we're multiplying times that. Okay? Square root of 320. That's going to be way up here. So what's the largest perfect square that goes into 320 evenly? It's going to be 64. And it's 64 times 5 is 320. The square root of 64 is 8. So we're doing 4 times 8 and then square root of 5. 4 times 8 is 32. So our answer here is 32 square root of 5. Okay. The next one, this is a cubic root. So now we're looking at our perfect cubes list. That 2 is multiplied times. And remember, when you have a cubic root, make sure you are writing the index of 3. Don't forget that. Otherwise, it's going to look like a square root. Okay, so the largest perfect cube that goes into 48 evenly is going to be 8. And it's 8 times 6. So you say the cubic root of 8 and the cubic root of 6. The cubic root of 8 is 2. So you say 2 times 2, cubic root of 6. And 2 times 2 is 4, cubic root of 6 is our answer. Okay, number 4. So 3 times the cubic root of 108. 3 times, okay, 108 falls right here. Work your way down. The largest perfect cube that goes into 108 evenly is 27. And that's 27 times 4. So you say cubic root of 27 and cubic root of 4. The cubic root of 27 is 3. So that's 3 times 3 cubic root of 4. 3 times 3 is 9. So the answer is 9 cubic root of 4. That's our answer right there. Okay, flip over to the other side. Number 5, cubic root of negative 250. Still looking at the perfect cubes list. The largest perfect cube that goes into negative 250 evenly is negative 125. Now, we always want to take the negative out of the radical. So remember, the first radical is always the one that is your perfect square or perfect cube, whatever it is. That's the one that your negative is always going to go into. So the one you can simplify, the first one, is always going to be the negative, okay? And that is negative 125 times 2 is negative 250. The cubic root of negative 125 is negative 5. So we have negative 5, cubic root of 2 is our answer. Okay, the next one, we have 6 times the cubic root of negative 2. Okay, the only thing we want to do here, because you can't take the cubic root of 2, the only thing we want to do is we want to get that negative out. So we have the cubic root of negative 1 and we have the cubic root of 2. The cubic root of -1 is -1, so 6 times -1, and then cubic root of 2. So that equals -6 cubic root of 2. So you always want to get that radical, you always want to get that negative out of the radical. Okay, the next two are fourth roots. So we're using our perfect fourths on this one. So this is 3 times the fourth root of 162. So the largest perfect fourth that goes into 162 evenly is 81. So fourth root of 81, and it's 81 times 2 is 162. Fourth root of 2. Okay, the fourth root of 81 is 3. So this is 3 times 3, fourth root of 2, which equals 9 fourth root of 2. Okay, number 8, we have 5 times the fourth root of 2,592. The largest perfect fourth that goes into this is 1,296, and it's that times 2. So fourth root of 1,296, fourth root of 2. The fourth root of 1,296 is 6, so it's 5 times 6, fourth root of 2. Well, 5 times 6 is 30, so our answer is 30, fourth root of 2. Okay, all right, radicals with variables. So square roots, exponents must be multiples of 2. Cube roots, exponents must be multiples of 3, and fourth roots, exponents must be multiples of 4 to be able to simplify them down. Okay, we're still doing the same thing like what we did with these. You're still breaking it into the 2 radicals that one that you can simplify and one that you cannot. And we want to do the same thing with the variables. Okay, so for 32, we're talking about square roots here because there's no index. So what's the largest perfect square that goes into 32 evenly? It's going to be 16. So you have 16, and 16 times 2 is 32. So the one we can simplify, the one we can't. Okay, if the exponent divides by 2, you can put it in the first one right here. If not, you have to subtract it by 1, write that here, and then the leftovers you put over here. Okay, 4 divides by 2, so that means we can simplify x to the 4th, so it goes right there. 9 does not divide by 2, so subtract 1 out, so we have 1y over here, and that leaves us with y to the 8th in the first radical that we can simplify. Okay, now we want to simplify this down. The square root of 16 is 4, and when we take the square root of these, we're just dividing them by 2. So that's x squared and y to the 4th. And we still have the square root of 2y is left over. And that's our answer. Okay, 324, we actually can take the square root of 324, so that whole thing is going to go in the first radical. Okay. You cannot divide 3 by 2. So a leftover a goes here, and that leaves us with a squared in the first. You cannot divide 7 by 2. So a leftover b goes here, and b to the 6th goes in the first one. The square root of 324 is 18. The square root of a squared, well, 2 divided by 2 is 1, so it's just a. 6 divided by 2 is 3, so it's b to the power 3. And bring down the square root of a, b. Okay, now we're looking at cubic root. Cubic root of 216. We can take the cubic root of 216. 3 divides by 3 and 6 divides by 3. So this one, we don't have to break it into 2 radicals because you can take the cubic root of all of those. So the cubic root of 216 is 8. 3 divided by 3 is 1, so we just have n. 6 divided by 3 is 2, so it's n squared. And that's our answer. Number 12, cubic root of 56, can't do that. So the largest perfect cube that goes into 56 evenly is 8. So we have the cubic root of 8, and that's 8 times 7. Cubic root of 7. Okay, 8 does not divide by 3. So we have to get that to a number that will divide by 3. 7 doesn't divide by 3, but 6 does. So that means that we are getting this down to r to the 6th. So that r squared is going to go over here in the radical we cannot simplify. 4 does not divide by 3, but 3 does. So we're getting that down to an s cubed, and that extra s is going to go over here in the radical we cannot simplify. So the cubic root of 8 is 2. 6 divided by 3 is 2, so r squared. 3 divided by 3 is 1, so s. And then we pull down the other radical. Okay, 13. The cubic root of negative 64, we can take that. So it's going to go in the first radical. 10 does not divide by 3, but 9 does. So we get that down to x to the 9th, and then we have an x left over in the second radical. 21 does divide by 3, so that goes in the first radical. Okay, the cubic root of negative 64 is negative 4. 9 divided by 3 is 3, so x cubed. 21 divided by 3 is 7, so y to the 7th, and then bring down the cubic root of x. Okay, cubic root of negative 81, we cannot do that. So the largest perfect cube that goes into negative 81 evenly is negative 27. So we have the cubic root of negative 27, and that leaves us with the cubic root of 3 over here. 2 does not divide by 3, and you cannot get that down to a number that will divide by 3 because it's less than that. So the p squared has to go in the second radical. 12 does divide by 3, so q to the 12th goes in the first radical. The cubic root of negative 27 is negative 3. 12 divided by 3 is 4, so q to the 4th, and then bring down the cubic root of 3p squared. 15, we're looking at 4th roots here. 4 divides by 4, 17 does not divide by 4. So in the first radical, we have w to the 4th. Okay, in the second radical, 17 doesn't divide by 4, but 16 does. So we can put v to the 16th in the first, and that leaves us with a v in the second. 4 divided by 4 is 1, so it's just w. 16 divided by 4 is 4, so v to the 4th, and then bring down the 4th root of v. Okay, 4th root of 48, you can't do that, so the largest perfect fourth that goes into 48 evenly is 16. So you have the 4th root of 16, and that's 16 times 3. So 4th root of 3. 8 divides by 4, so that whole thing goes in the first radical. 3 does not divide by 4, and you cannot simplify that any, so that whole thing goes in the second radical. So the 4th root of 16 is 2. 8 divided by 4 is 2, so m squared, and then pull down the second radical. Fourth root of 625. You can take the 4th root of 625, so you bring the whole thing down. Okay, 23 does not divide by 4, so we have to get that down to a number that does divide by 4, which is 20. So c to the 20th, we can put in the first. In the second radical, well, 23 minus 20 is 3, so c to the 3rd goes here. 11 does not divide by 4, so get that down to a number that does divide by 4, which is 8. So d to the 8th, and that leaves us with d to the 3rd in the second radical. The 4th root of 625 is 5. 20 divided by 4 is 5, so c to the 5th. 8 divided by 4 is 2, so d squared. And then bring down the 4th root of c cubed, d cubed. Okay, last one here. Notice that this whole thing is in parentheses and it's to the power of 8. Okay, so all you have to do there, because 8 divides by 4, you're just taking the 4th root of that 8 right there, which is y plus 3 squared, because 8 divided by 4 is 2. Okay, so then to simplify this, you're just squaring that, and you can actually use your reference sheet, you know, at the top of your reference sheet, where it says the perfect square trinomials. So you take the first term and square it, which is y squared. And then because this is addition right here. Multiply these two together, which is 3y, then multiply that times 2, which is 6y. Take the second term and square it, which is 9, and that is our answer. Okay? All right, so this is nth roots and simplifying down radicals.